My YouTube channel. In this video lecture, I am going to answer questions from sample paper number 6, RK Bali Navigation Book. This is the fourth revised edition of this RK Bali Navigation Book. Nevertheless, all the questions from sample paper, from all the questions from this sample papers, whether you take them from, whether you read them from revised edition 5 or 6 or 7, whatever, however there are. So these questions are not going to change. All the questions are the same in different books. So even if you solve these questions, no problem. Practice is important. Conceptual understanding is important. Getting to know how to solve these sums is important. Building confidence is important. So with that purpose, we are solving this questions from this particular video lecture. So let's start with question number 1. Aircraft flies from position 50° north, 175° west to a new position which is at same latitude 50° north but different longitude 175 east, crossing the international date line. The observer should. So I will draw two different pictures, diagrams for this. So one this. So here is your North Pole. So we are looking at the Earth from the perspective of the North Pole, from the top of the North Pole. This is your 180° east-west meridian. This is 90 east. This is 90 west. Right? You are currently at 175° west and you are traveling to 175° east. Okay? Across the international date line. Now this is the anti-meridian. This line is nothing but the anti-meridian of prime meridian 0°. Okay, and you are traveling from west to 175 west to 175 east, meaning you are flying in the direction of 090. All clockwise directions are 090, anti-clockwise directions are 270 or westerly directions. So whenever you cross this international date line, what change happens? So remember, whenever you travel from western hemisphere to eastern hemisphere across the international date line, date increases in value. For example, 10th July will become 11th July when you enter the eastern hemisphere. Okay, 10th July will become, correction, all clockwise directions are westerly. Okay, and anti-clockwise directions are easterly. So yeah, so 10th July will become 11th of July. And what happens to day? Day, a day is lost. A day is lost, meaning when the date becomes 11th July from 10th July, you get transition or you get thrown into an additional day, a new day which is 11th July. That means you have been pushed to a future date. So when you go forward or go forward towards a future time to a future date, what you lose is you lose a particular day and you lose a day. So a few minutes ago you were living on the day of 10th of July. Now suddenly as soon as you cross that international date line, you are living a day of 11th of July. You may not have lived entire duration of 24 hours, but just because you have crossed that international date line within few hours, next 2-3 hours, you directly are now living a day of 11th July. So that means you are at a disadvantage. You have lost one day. So that is the problem when you go from western hemisphere to eastern hemisphere, you lose a day. But when you travel from eastern hemisphere to western hemisphere, you gain a day. you get an extra day to live. Okay, just theoretically. Okay, so a day is lost. So the answer is the observer should decrease the date, increase the date, increase the date. So like here, it's the date. What happens to the value? Date increases in value. So increase means you have to add. So eliminate option alpha. We are left with Bravo and Charlie. Increase the date, yes. What happens to time? LMT increases, LMT decreases. LMT increases or LMT decreases. So what will happen is the local mean time will definitely increase. Okay, because eastern longitudes are always running, eastern longitudes are always running ahead in time compared to their respective western longitudes, compared to their western longitude. So here you are traveling from west longitude to east longitude. So east longitude will definitely be running ahead in time compared to its west longitude. So the correct option will be option Bravo. Local mean time increases. So pretty conceptual question. So do watch all my time lectures. I have also solved the time related questions from RK Bali GenNav book, Oxford GenNav book, Keith Williams GenNav book. I have uploaded them to the dedicated playlist. I have made each for RK Bali GenNav, Keith Williams GenNav and Oxford GenNav. So do watch them. A co-located VOR-DME is being used to track on airway inbound on 160 radial. On 160 radial. At 60 miles, not at 60 miles from the DME, the VOR indicates 336 on the OBS. Let me check the question again. So a co-located VOR DME is being used to track an airway inbound on 160 radial. 60 nautical mile DME, VOR indicates 336 on the OBS and from indicator reads 2. So let's draw this. Here is your VOR DME station. Okay, VOR DME station. This is your north datum and you're tracking 160 radial inbound. So let's draw two radials. Radial 160, the reciprocal of which is radial 340. Now you're tracking it inbound at 60 nautical mile range. Okay, that means your position is something like this. You may be heading some other direction also, but for as of now I have drawn a position of aeroplane which is heading towards the URDME station inbound. Now OBS, let's draw OBS. 336 and the from indicator to indicator reads to indication. So 336, that means you have set your OBS to radial 336, the reciprocal of which is 336 minus 180, 156. Okay, 156. So that means you have set your OBS to a setting of 336 and you want to track inbound. That means, so let's analyze this situation. Currently you are on radial 160 flying inbound. If you continue flying inbound on this particular radial, you will, after some time, you will overfly this VOR-DME station and then you will transition onto the opposite radial 340 and then start tracking it outbound. But now here we have not set 340 in the OBS, we have set 336. So that means in order to get onto radial 336, which is here, we will have to first turn your aircraft to the right hand side like this, intersect this radial 156 here and then start tracking this radial 156 inbound towards VOR-DME station. Okay, so when we start tracking this radial inbound, radial 156 inbound, overfly VOR-DME station and transition onto radial 336 automatically. In that case, this scenario will be suitable. But if you don't make this change in your heading and intercept this track, what will CDI show? If you continue flying this track, CDI will give some indication. Now flying inbound, this is your left side, this is your right side. So the CDI will tell you to fly right hand side because the radial that you have selected 336, the reciprocal of which is 156, is to the right hand side of your current aircraft position. So the CDI will move right hand side. The CDI will move right hand side. Okay. And by how many dots right hand side? The difference between 160 and 156 is 4 degree. A 4 degree angle equals to how many dots? 1 dot equals to 2 degrees. So 4 dots, 4 degree angle will be equal to 2 dots. So that means your CDI needle will move 2 dots to the right hand side. So the aircraft position is VOR. CDI needle indicates 1 dot to the right, 4 nautical miles left of the center line, 4 nautical miles starboard of the center line. So CDI, one thing is for sure, CDI should show 2 dots to the right. Here the option is 1 dot to the right. Option Bravo is 4 nautical miles left. Option Charlie is 4 nautical miles starboard, meaning right. So definitely we are to the left hand side. But by how many nautical miles we do not know that. So let's draw this triangle. So this triangle will look something like this. Your aircraft is currently here. It is 60 nautical miles away as given in the question. The angle is 4 degree. Correct? We have to find this off track distance. So let's use 1 in 60 rule. Track error angle, distance off track divided by distance traveled into 60. So x is equal to 4 nautical miles. So that means you have 4 nautical miles to the left hand side of your intended track. So you are Bravo, 4 nautical miles left hand side. Important question, practice this many times. Question 3. Radio altimeter determines aircraft height by what? So you must understand the principle of operation of your radio altimeter. The radio altimeter shows the height of aircraft with respect to the ground below it, directly below it. Okay, so let's say this is your ground surface. Here is your aircraft. It is going to send a continuous wave signal, which is frequency modulated towards the ground surface. Okay, and when this wave signal gets reflected from the ground surface, it will get reflected at a different frequency modulation. Okay, so aircraft will come to know whether this wave that is getting reflected, is it getting reflected from the ground surface below, or is it getting reflected from some other obstruction like mountains, buildings, towers around the aircraft. Aircraft is concerned about the reflected signal from the ground surface, not any other obstruction around the aircraft. So this reflected signal will be detected or will be received and detected by aircraft receiver. And how will it determine whether it is correct signal or not? It will check the frequency modulation. The frequency modulation will keep on changing. The frequency modulated transmitted will be different from the frequency modulation received. Okay, the speed is known to you, 3 into 10 raised to 8 into meter per second, and the time that it has taken for the signal to go and come back. So when you know the time and speed, you can use distance speed time formula to calculate distance. Okay, this distance we are talking about is vertical distance between your aircraft and the surface beneath it. So this is the operation of your radio altimeter. So it measures the time interval between outgoing and incoming signals, employs pulse modulation, comparing the frequencies of the outgoing and the incoming signals. So the correct answer here will be, comparing the frequencies of the outgoing. Yeah, option Charlie. Okay, 3 will be option Charlie, comparing the frequencies of the outgoing and incoming signals. That is what it is, that is the principle it is based on. Now, measuring the time interval between outgoing and incoming signal is more like primary radar. Next, question number 4. Listed below are factors which change density altitude. It can change density altitude in a good way or in a negative way. Decreasing barometric pressure, yes. Now remember, your density altitude is governed by three factors. Is governed by three factors: pressure, humidity, temperature. Right? By these three factors. Now, decreasing barometric pressure. Whenever atmospheric pressure decreases, density of air, density of air decreases. When density of air decreases, density altitude increases. Increasing barometric pressure. Whenever atmospheric pressure increases, density of air increases. Density altitude in that case will decrease. It's good. It's good for performance. Decreasing temperature means cold temperatures increase the density of air. So density altitude will decrease. Increasing temperature, hot temperatures will decrease the density of air. Density altitude will uh, increase. Decreasing humidity, increasing humidity. So if humidity of air decreases, that means it's getting more, it's becoming more and more dry. It's becoming drier and drier. So dry air is beneficial for aircraft performance. Humid air or moist air is not good for aircraft performance. So that will also impact density altitude, right? So select the factors which increase the density altitude. Okay, which increase. So density altitude is increased by option A, option delta, alpha delta, and this will be this particular option. Increasing relative humidity will be foxtrot. So it will be foxtrot. So option Charlie, alpha delta and foxtrot. Alpha delta and foxtrot will increase density altitude. If a flight is made from an area of low pressure into an area of high pressure, so let's say this is your area of low pressure and this is an area of high pressure. So low pressure and high pressure. Okay. So you are traveling from low to high pressure area without altimeter setting being adjusted. Means you are not updating your altimeter setting window. You are not putting a new QNH value. And a constant indicated altitude is maintained. What will happen? The altimeter would indicate what? So in low pressure area, the true altitude of your aircraft is less than indicated altitude. In high pressure area, the true altitude of your aircraft is more than the indicated altitude. So when you are going to a high pressure area, your altimeter might indicate 5,000 feet, let's say, but true altitude will be more than 5,000 feet, let's say 6,000 feet. So you're basically safe in high pressure area, but in low pressure area, true altitude is less than indicated altitude. So indicated altitude by altimeter may be 4,000, let's say, but your true or real actual altitude will be much less than that, 3,500, 3,000, something like that. So that is unsafe. So the altimeter would indicate actual altitude, the correct altitude, no. It will indicate higher than the actual altitude, no. It will indicate lower than the actual altitude, yes. In a high pressure area or warm temperature air mass, the altimeter indicated altitude, that is the altitude indicated by the altimeter, will be less than the true altitude. Okay, so don't get confused. Next, if PNR is calculated to be 880 miles with first 10,000 kg of fuel available, the distance to the PNR with a new fuel, additional fuel of 11,000 kg, okay, new fuel of 11,000 kg correction, will be what? So always remember, it's a property, it's one very important property of PNR. An increase in fuel percentage will be accompanied by increase in PNR distance by the same percentage. So let's say in this example, your original fuel is 10,000 kg. Initial fuel is 10,000. New fuel is 11,000. New fuel is 11,000. So what is the percentage increase? Percentage increase equals to new minus old divided by old into 100. 11,000 minus 10,000 divided by 10,000 into 100. So 1,000 into 100 divided by 10 is 10% increase. Increase of 10%. So similarly, PNR distance will also increase by 10%. So old PNR or initially PNR was equal to 880. So new PNR will be more than old PNR because it has to increase by 10% of old PNR, by 10% of old PNR. Old PNR is 880. 10% of that is 88. So 880 plus 88, 968 nautical miles. So new PNR distance is Bravo, 968. Important, very important. Next, under which of the following circumstance will GPWS not give warning? So remember all the modes of GPWS by heart. I have uploaded one video lecture in which I have marked important points from this particular chapter, GPWS Oxford Radio Nav, and I have marked all the important points of that chapter and uploaded them to my YouTube channel. So watch that video. You will find that in one dedicated playlist of important points, Oxford Radio Nap or Oxford Instruments like that. So you'll find it there. Similarly, I have also marked important points from TCAS, Oxford General Navigation chapters, some instrument chapters. So do watch them. Now, there are 7 modes of GPWS: excessive descent rate, excessive terrain closure rate, descent after takeoff, unsafe terrain clearance because landing gear is not lowered down or flaps are not lowered extended. Whenever you descend below glide slope by more than 1.5 dots, situational awareness like bank angle and wind shear information. So the correct option here is you do get a warning whenever you are approaching below certain altitude, certain height correction without extending your flaps. So you do get that warning, yes. You also get a warning when you are approaching towards the runway without landing gear locked down. But you do not get a warning about rising ground ahead. So correct option is option Charlie. A normal ground proximity warning system will not give you a warning of the ground that is ahead of you, a dangerous rising terrain, rising ground, mountain in front of you. It will only give an indication of the ground, of the clearance between you and your ground just below you, but not ahead of you. This rising ground ahead is a characteristic feature of enhanced ground proximity warning system. That enhanced ground proximity warning system is capable of giving that kind of warning, but not a conventional old version ground proximity warning system. When fitted with Mode C transponders, a TCAS-2 system may provide what? So there are two types of TCAS. One old TCAS called TCAS-1, and it can only generate traffic advisories. Okay, it can just tell you where the position of the traffic around you, whether it's the distance it is away from you and the relative bearing of that aircraft with respect to your aircraft, whether that aircraft is to your right hand side, left hand side, directly in front of you, like that. So just a traffic advisory. A newer system, a much advanced system, TCAS-2, generates traffic advisories, and if need be, it can also produce a resolution advisory. Traffic advisory is just the information of that traffic around you. Resolution advisory is the solution, is an avoiding action told, given to you, instructed to you, and you must follow that instruction. So that instruction that instructed to you by the system, TCAS system, okay, and that resolution advisory is given depending on mode C capability in your transponder, whether your transponder has that capability or not. If it does have mode C capability in it, you will be given a resolution advisory. Your aircraft will come to know the height of your aircraft you are flying. Let's say you are flying at 1000 feet, and the height at which your traffic is flying is 2000 feet. It is above you. So the relative distance between you and the aircraft traffic above you is 1000 feet. So that means if that aircraft gets very close to you, so you will get a resolution advisory of descent because that aircraft is above you. So you will definitely not get a climb resolution advisory, a climb command. Because if you start climbing, you will get much closer to that aircraft. So the only solution to this proximity situation is descent. You have to descend. That aircraft must continue climbing level or ascend, but not descend. So mode C transponders enable the production or generation of resolution advisories. Okay, so resolution advisories, next very important thing, are only given in vertical plane. You can only get a resolution advisory of climb or descent, not left turn or right turn, not yet. Okay, next. Question 9. I have solved all these DME related questions, radar questions from Keith Williams, Oxford, and uploaded them. So do watch those lectures and solve that questions as well. More practice, more perfection. So if the pulse length used in a primary radar is 4 microseconds, what is the minimum range at which a target can be detected? So minimum range is proportional to pulse width. So it is pulse width multiplied by speed of light divided by 2. What is pulse width, it is 4 microseconds into 3 into 10 raised to 8 meter per second into 10 raised to minus 6. Convert microseconds into seconds divided by 2. So 2 into 3 into 10 raised to 2. So that is 600 meter. Option Charlie. 600 meter. Question 10. If aircraft with two static ports side slips towards the block port, what will be the altitude indication? So all your aircraft have two static ports. Let's say this is your north datum and this particular aircraft is flying north, is flying in the direction of north. Okay, it's flying in the direction of up north. That is the head, this is the nose of your aircraft and this is the tail section. Now this aircraft will have two static poles, one on each side of the fuselage. So this is done in order to have correct static pressure registered in the pressure system and in turn get correct altitude indication. Now let's say why is this? Now let's say if your aircraft had only one static pole, one on left side or maybe one on the right side, but only one. So if you start side slipping towards right hand side like this, if you start side slipping to the right hand side, this is the direction of your track, but you start side slipping to the right hand side like this, and there is a static port to the left hand side. There is only one static port to the left hand side. What will happen? When you start side slipping to the right hand side, there will be additional airflow coming here, coming from this direction, relative airflow, and striking this part of your aircraft, the right side of your aircraft. Whereas the left side of your aircraft, where the static port is situated, the static opening is situated, will not be exposed. Okay, it will be not be exposed to this additional dynamic airflow that is coming from the front. Okay, so we can just say that this static port, which is on the left side of your aircraft, will be shielded or protected, will be protected from the incoming or the oncoming relative airflow. Relative airflow. Okay, that means as a consequence of this, there will be more, much more static pressure on this side of aircraft. What kind of additional pressure? The normal static pressure plus dynamic pressure. But on this side of aircraft, there will be little less static pressure because this side of aircraft is not exposed to the relative airflow. It gets protected from the incoming airflow. Okay, so the pressure that it will sense, this static port will sense, will be much less than it has to sense or it has to register. As a result of that, what happens is, as a result of that, there is an imbalance. Imbalance is created. One side experiences much more pressure than needed. The second side experiences much less static pressure than it must register. So, so as a consequence of this, the altitude indicated will be incorrect, will be wrong. So in this case, in this particular case, the altitude indicated will be over. Altitude will over indicate. Why? Because since this static pressure is registering less static pressure than required, than expected, less static pressure means more altitude. You will find less and less static pressure as you climb to higher and higher altitudes. So this less static pressure is translated into our higher altitude information. That means you may be flying a constant altitude of 4,000 feet, but because of this less static pressure getting registered, your altimeter will show a higher altitude, let's say 4,500, 5,000 feet. So it will over indicate. Okay. The opposite will happen if you are flying in a right side slip condition and the static port is located on the right hand side and there is no static port on the left hand side. Okay, so in order to break this imbalance, in order to get rid of this imbalance produced by only one static port on one side of aircraft, we have two static ports, one on both side of the aircraft, of both side of the fuselage. So that means more pressure generated here on this static port will be counteracted or will be cancelled or will be balanced by less pressure generated on the other static port. So the overall result will be plus minus 0. Okay, and therefore the altitude indicated will be the correct altitude. So in this particular example, let's say you are side slipping towards the block port. You are side slipping towards the block port. So let's say this is your aircraft. It is side slipping towards the right hand side, and it has two static ports, one on the left hand side, another on the right hand side. The right hand static port is blocked. That means it is not available. The left hand static port is working fine. Now the relative airflow which is coming from the head on, from the 12 o'clock position, right from the front, will create impact pressure, here, and therefore pressure on this side of the static port will be much more than expected. On the other hand, the static port which has gotten shielded, which has gotten protected from this incoming airflow, and which has also gotten shielded from the surrounding atmospheric pressure, will register less static pressure than one required or expected. So now this port is blocked completely. That means your altimeter will get static pressure information directly from only left static port. Now left static port is registering has registered less static pressure. So less static pressure translate into will translate into more altitude information, more altitude or higher altitude indication. So over indication will happen. So the correct answer here will be the altitude indication will increase. You may be flying constant for 4,000 feet, but altimeter will show something more than that depending on the magnitude of error. Okay. So this concludes our lecture. I hope you have understood all the first 10 questions I answered in this particular video lecture. Very easy. Practice is the key. Conceptual understanding is the key, and therefore I always explain each and every question in detail, even though I may have done that many times before in my previous video lectures. So I wish you all the best. Share this video with your friends who are preparing for the exams, and subscribe to this channel if you haven't yet. And do hit the like button if you have liked this video lecture. Keep practicing, keep working hard. All the best.